This is a bad review received by liteVNA on Taobao. This is another bad review received on AliExpress. They all mentioned that liteVNA has obvious phase anomalies at higher frequencies, making high frequencies unusable. From the pictures he provided, there is no problem with our liteVNA, the problem should appear on the calibration. He provided some clearer pictures, and we can reproduce these issues to discuss the precautions required during the calibration process. Now simulate the user's usage process and calibrate liteVNA. Here, use the simple calibration device included with liteVNA. Connect the open circuit first, and then press the open circuit option of the menu. Next, connect the short circuit and click on the short circuit option in the calibration menu. Pay attention to the curve here, we will discuss later. And then the load. Then complete the isolation and pass through calibration in menu order. Let's speed up the video appropriately. After the calibration is complete, click Finish to apply the calibration. Now we remove the cable connection to port 2. Normally, the signal should be totally reflected at the end of the cable, but here there is a strange resonance. Let's take a look at the picture on the user's bad review again, and there is a similar error. It can be confirmed that we have reproduced the user's wrong operation. Measure another 3 dB attenuator. There is also an abnormal pit in the middle, and the phase also shows a strange bend. Now we use the same machine, the same calibrator, the same settings, to perform the correct calibration again. We reset the previous calibration first and then perform the same calibration as before. The only difference is that after screwing on the calibration piece, I use another force to tighten the calibration piece. Screw on open circuit and click open circuit from the menu. Next, screw on the short circuit calibration piece. Notice the curve change here during tightening. After tightening, click the short circuit option of the menu. Similarly, you need to tighten the load and press the load button in the menu. Isolation calibration, we leave 2 ports blank and click on the isolation option in the menu. For through calibration, we need to connect the 2 ports with wires, and we also need to pay attention to tightening the SMA interface. After the calibration is complete, click Finish to apply the calibration. Now let's disconnect port 2 of the RF cable. Now we see that the phase is continuous, the return loss is also continuous, and the liteVNA performs well in the frequency range up to 6.3 GHz. We tested the 3 dB attenuator again, and the return loss was between 5.8 dB and 6.2 dB, which met the measurement expectations of the 3 dB attenuator. The phase measurement was also accurate, confirming the accuracy of the liteVNA reflection measurement at high frequency. Although we have proven the cause of the problem, there are still users who doubt whether this problem only occurs on low-cost liteVNA, so we are also replicating the same error on expensive laboratory-grade vector network analyzers. We connected the ordinary SMA adapter on the expensive phase stabilization cable in order to connect the ordinary SMA simple calibration piece. During the calibration process, you can notice the abnormal curve when the short circuit is not fully tightened. After performing the wrong calibration, we connected the same cable as the liteVNA measurement and could also see a similar curve anomaly, reproducing the same error. Now, let's take a closer look at why tightening the SMA connector is important for calibration. During the tightening process of the SMA connector, the outer conductor nut of the female head is first screwed by the screw sleeve of the male head, but the real outer conductor of the male head is not the screw sleeve. The real screw sleeve is inside the connector. Only after it is fully tightened can the inner and outer conductors of the connector be fully in contact to achieve good impedance matching. Now you see that because the connector is not tightened, a cavity with discontinuous impedance is formed between the inner and outer conductors, forming a strange resonance that makes the measurement results completely wrong. The vector network analyzer itself is a device for measuring the quality of the connector. Whether calibrating or connecting the device under test, attention should be paid to the reliability of the connector connection. We were also able to reproduce abnormal resonances caused by incorrect connectors on laboratory-grade vector network analyzers. Finally, it is important to note that SMA connectors are not precision connectors and have a limited lifespan. We will use more durable 3.5mm precision connectors on more sophisticated devices in the future. No matter what kind of connector is used, it will wear out after long-term use, and the reliability of the connector needs to be checked regularly.